During the Olympic Games, there is a lot of talk about pressure. Normally, people are referring to the mental stress and high expectations that athletes might feel during intense competitions. However, there are other kinds of pressure at play, both in the Olympics and throughout our lives. In science, pressure is defined as the amount of force over a given area. This means you can have the same amount of force over two different areas and end up with different results. For example, imagine you are walking along a snowy field in your boots. With each step you take, you sink into the snow. However, if you strap on snowshoes, you can walk without falling in as much. The change you made was to increase the area over which the weight or force was being spread. The increased area of the snowshoes, compared to your boots, has decreased the amount of pressure on the snow, allowing you to smoothly walk without penetrating the surface of the snow as deeply. This concept of pressure is also present in many Olympic sports. Rowing is one event where force per area is very important. Once rowers place their oars into the water, they use the strength of their bodies to put as much force as they can onto the area covered by the oar's blades. Whichever boat can do this in the most synchronized fashion is likely to win the race. Pressure can exist in solids, liquids, or gases, and we can measure it in objects found in space. The pressure found within the hot gas that permeates a galaxy cluster is very low, about 17 more orders of magnitude, that is, zeros beyond the decimal point, than what we find in human blood pressure. On the other hand, we also find cosmic objects that experience extremely high pressures, such as in the interiors of neutron stars. In the cores of these collapsed dead stars, pressure can reach 1,000,000 trillion times that of the air pressure we experience here on the surface of the Earth. In fact, pressure may have the greatest range of all physical variables, spanning over 60 orders of magnitude from the vacuum of space to the densest stellar cores in the universe. Whether it is in the center of a star or at the center stage of the Olympics, pressure can be significant in many ways.